Okay, so number 9, page 20. The function f has a derivative. Or f have a relative max. So you know that if you're looking at your f prime graph, your x-intercepts are going to be your potential critical points that will help lead you to a relative max, relative min. So you know that your critical points are at 0, 3, and -1. This is a non-calculator. Okay, non-calculator. So if we set f prime equal to 0, we get x equals 0, 3, and -1. Create your f prime sign line. Test each subinterval. So if I plug in -2, and for x, I'll get I can just ignore the middle one because that squared is always going to force every value to be positive. So negative times negative is positive. So I know that this interval is increasing. If I plug in -1/2, I get negative times positive, which is negative. And if I plug in 0, sorry, if I plug in 1, I get positive, positive. If I plug in 4, I get positive, positive. Right, so relative max is going to be at -1 and only a -1.
The more complicated way with the what's called second derivative.
Oh, you just second derivative. Yeah. I think it's good to have that knowledge in the back of your head. But yeah, yeah, you can definitely find the second derivative function as well, but that feels more complicated.
Yeah.
It's good. It's a good test though. You're going to see it probably show up on the AP exam at least once, at least some reference to second derivative test. Okay, number 10, let f be the function defined. For what value b is the function continuous? So anytime I see a piecewise function, I know I'm going to, and they've mentioned the word continuous, I know I'm going to step through. For me, if I step through continuity conditions, it just feels like it's a nice structure for me to walk through for all my continuity issues, continuity problems. Okay, so I know that the x value in question is 2. So I'm centered at 2. So I want to find f of 2. f2 equals b. It's still unknown, but I can just gather some information here. Second condition. I know that if I want to find a limit is only going to exist for connected parts of graph. It's never going to involve the order pair. So the connected parts of graph is with that first piecewise. So limit as x approaches 2. If I plug in 2, I'll get 4 minus 14 plus 10, which is 0. I get 0 over 0. I can do L'Hopital's rule, or I can just go through and factor. Reevaluate. I'll get -3 over b. So now that I've gone through my first 2 conditions for continuity, my third condition is just looking back and seeing, okay, what value will allow this to be true? When is b going to be equal to -3 over b? And here, if I try to solve for b, I'm not going to be able to get to a real number. So b squared equals -3. No value for b, no real number for b can allow me to get -3 in return. So we know that there is no such real number value for b. Okay, between 0 and 6, the graph of f prime is shown. What is the maximum value of f on the interval? So remember, this is the derivative graph here. So I'm just going to label the parts to help me visualize what the original graph would look like. My critical points will be at, and I'm starting at 0 and ending at 6. Critical points will be at 3 and 5.5. X-intercepts. Above is increasing. Below is decreasing. Above is increasing. So the maximum value could be at 3, but could be at 6 as well, right? If the graph is rising and falling and rising, my candidates are going to be 3 and 6. Because I know relative min can't be, right? And if I'm rising to get to 3, I know 0 can't be either. So I know f of 0 is 1. Okay, so if I can find f of f of 3 and f of 6, I can just compare those to see which one will give me the maximum value. So f of 0 is 1. And then from 0 to 3, I can just figure out the area of that triangle here, 1/2 base times height, 1/2 4 times 2, which is going to be just 4. Wait, sorry, not 3, not 4, 3. 1/2 3 times 2 is going to be 1 plus 3, which is 4. Yeah, actually, I can tell by looking at this that there's no way that I'm going to be able to achieve a higher value than this, because here, from here, I'm going to be decreasing a lot more than I'm increasing here. So the area here is larger than this. So I know I'm going to be a little bit more rising, but not enough for me to overtake the largest value at 3. So I know I can just stop and say that max value must be 4.
I didn't ever learn whatever the base times height stuff is. I just kind of look at this, look at the graph.
Oh, that's fine too. Yeah, yeah. Oh, I just found the area using, I just do the area of a triangle here. How did you do it?
What does that mean?
Oh, the area of the triangle is the displacement of, so I think of it as a particle motion problem, right? If this is the velocity graph, the area under the velocity graph is going to be displacement. So if I start at 1, and if I move 3 units to the right, I'm going to end up at 4. So
It's kind of like magnitude stuff. Yeah.
yeah. It's also just a rearranging of first theorem as well. This is the first fundamental theorem of calculus there. Okay, number 12. Let f be the function given by f of x equals 9 to the x. So it's helpful to just have an idea what that graph looks like. You don't have to be super exact. Also, there's no calculator. So, but you know that exponential function looks like this. Right? It's going to just ever increasing slope to the right. Okay, what's the value of the right Riemann sum approximation if I'm doing 4 subintervals of equal length between 0 and 2? Okay, so my width is going to be b minus a over n. I want to split that interval of 2 into 4 parts. So each interval is going to be 1/2. So I'm going to attach 1/2, 1, 3/2, and 2 to the graph, and that's going to indicate my height. And then with the right Riemann sum, I'm going to do width times height. Okay, I know my width is going to be 1/2 all the way through. And my height is just going to be whatever I get from that 9 to the x. So f of 1/2 is going to be 9 to the 1/2, which is 3. F of 1 is going to be 9 to the first power, which is 9. F of 3/2 is going to be 9 to the 3/2, which is square root of 9 is 3. 3 cubed is 27. F to the 2 is the same thing as 9 to the second, which is 81. So width times height, every width is 1/2. 1/2 times 3 is the first rectangle. 1/2 times 9 is the second rectangle. Third rectangle, 1/2 times 27. And then finally 1/2 times 81. $13, pretty straightforward. Quotient rule. You have to apply quotient rule and clean it up to match one of the answer choices. Notice that they prepared an answer choice for students who are trying to get the shortcut numerator, denominator, numerator, derivative, denominator, derivative. This is not how we do quotient rule, but you can tell that they do have answer choices for students who may not exactly follow the rule, but has a answer choice for as a bait for students who are not working through the problem fully. Okay, 14. Okay, velocity of the particle is given. Initial point is also given. So I know my final location is initial plus displacement. So I set up my formula, but you know, I can't just plug in the calculator. I got to do this by hand. So I got to go through U substitution, let the U value be 2t, clean everything up, pull the 1/2 out. Integral of sine is a positive cosine. Sorry, negative cosine. Bring back your original variable, plug in your upper and lower bound. I need to remind students to make sure you review your unit circle values this weekend. So cosine of pi is -1, cosine of 0 is 1. Clean that up, that ends up being 1, so 4 plus 1 is 5. Okay. The function g of x is differentiable and increasing for all real numbers. On what interval? is the function g of x cubed minus 6x squared increasing. So you know that anything that deals with increasing, decreasing has to come from the derivative. So we have to find the derivative, but a little bit strange because this is kind of stuck in function notation. So we have to go through chain rule, but keep track of those, function portion of it. So g of u is a g prime of u times u prime, right? So we got to do outsized derivative times insized derivative. So outsized derivative is g prime of x cubed minus 6x squared. And the insized derivative is going to come out 3x squared minus 12x. Now we know that g of x is increasing. Okay. So if it's increasing for all real numbers, we know that g prime, this portion is always increasing. So we just focus on that 3x squared minus 12x. We can find our critical point, set that equal to 0.
Can you explain that one more time? Like, why you don't use the G prime stuff? Only the outside.
Right, because we know that if g of x is always increasing, then we know that g prime of whatever value that I can insert is always going to be increased, always going to be positive as well.
Okay.
So I know that this piece is positive, but this piece may impact g prime getting pushed up or down in terms of the slope.
Okay.
So we know this portion is positive, but we just have to focus on this part. That's going to give us some critical points. So I'm just going to set this equal to 0. So I get 0 and 4. Testing those values there. Test -1, test 1, test 5. So I plug -1 here. Negative times negative is positive. Positive times negative is negative. Positive times positive is positive. Technically, we're also testing this as well, but that's always positive, so it has no bearing. So we know that our g of x cubed minus 6x squared is increasing in these two intervals from -infinity to 0, and then from 4 to infinity. For 16, limit as x approaches 3 from the left side of 3. So it's not asking for the full limit, it's just asking for a limit as we approach 3 from the left. So this is not something that we can easily algebraically do. So we can either graph it or we just plug in the number and see where that leads. So let's say I tested 2.9 because 2.9 is approaching 3 from the left. So if I do 2.9 minus 3 over 2.9 minus 3, I'll get 0.1 over negative 0.1, which is -1. Now, technically, the true limit doesn't exist because there's going to be a split on either side. If I test at 3.1, it's going to be positive 1. So the graph actually looks something like this. But we didn't have to go that far. We could just plug 2.9 and see that, oh, my graph is headed towards getting closer towards -1 from that side. So I feel like we do have trouble if we see a constant, right? If there's so many letters in the problem, it tends to kind of throw us for a loop. So just keep in mind that if you see a constant, if they tell you that a is a constant, just pretend like it's a number and just put a number in its place. And just treat it like you would if it was a number, right? So imagine treating the same problem from this perspective, right? If this feels complicated, then solve this problem, right? The derivative of this is manageable, so we should be able to handle this as well, right? E to the u times u prime, same thing, e to the u times u prime. So you know your constant, your coefficient is not going to go anywhere. E to the u is just e to the u times u prime. Then the derivative of negative 3x is negative 3, so therefore the derivative of negative ax would just be negative a. So don't let any letters throw you off. If you really are struggling with it, just put a number in place of it and see if that will help remind you what to do with that constant. Okay, the two a's combine. Okay, next up, 18. I'm just solving the differential equation. I'm not even looking at these steps. I just want to step through it on my own, see how far I get, and then see where the steps, see where my steps don't line up with the incorrect one. Okay, so if I cross multiply, separate the variables, y is on the left, x is on the right, natural log on the left, power rule on the right, raise both sides, base e. I see the change is that this is not e to the x squared over 2 plus c, it's e to the x squared over 2 times c. So that's where the mistake comes. Huh?
I thought you did all.
No. I'm just pulling the key. Okay. 19 feels pretty straightforward. Point of inflection. However, this is deceptively easy because what a lot of students want to do is, students understand that, point of inflection comes from the second derivative. They find the critical values from the second derivative function, but they don't test with a sign line. So if there's no change in sign, it's not a point of inflection. So make sure that after you find your critical points at the second derivative level, that you're actually putting it onto a sign line and seeing there's a change in sign. So in this case, not every critical point is going to create a change in sign. So point of inflection is only going to exist at -2. Okay, so y prime is 15x to the fourth plus 40x cubed. Y double prime is 60x cubed plus 120x squared. Factor GCF. X is 0 and -2. Make sure that you don't just stop there and answer is E. You got to keep going. Create your sign line. Make sure that there's a change in sign. There's no change in sign to 0. So 0 is a candidate, but it ends up not being a point of inflection, just -2. Okay, number 20. Limit. If I see a limit problem, I'm just always going to plug in my x value and see what I get. Like a natural log of 5 minus natural log of 5 is 0 over 0. That indicates to me, okay, I can do L'Hopital's rule. So numerator's derivative is just u prime over u, 1 over x plus 3. Natural log of 5 is a constant, goes away to 0. X's derivative is 1, -2 is 0. Okay, reevaluate, see if it gets me a real number. 2 in for x, I get 1/5 over 1, same thing as 1/5. Okay, 21. Functions x, w, x, and y are differentiable with respect to time and are related by the equation w equals x squared y. We see time involved here, right? 1 unit per minute, 4 minutes, 4 units per minute. We have to recognize this as a related rates problem, okay? Which means that you have to make sure that you include all your d over dt. So you want the w dt to show up, dx dt to show up, and dy dt to show up, okay? But if you look at how the relationship is on the right side of the equation, we got to go through product rule because x squared and y are multiplied together. So we go through product rule, f prime g plus f g prime. That's the hard part. Once you can get your derivative built out, then you're just replacing your new variables with numeric values that they provide for you in the problem.
Shannon,
Mhm.
would you be able to teach me tabular method?
Mhm. So it doesn't work with natural log, but if it was like anything paired with either exponentials or polynomial paired with trig, then it works. So with this one, you can create u and dv. Your u is your x. This is BC, by the way, so don't worry about this here. So x cubed, 3x squared, 6x, 6, and 0. And then on the integral side, you're going to take the integral of e to the 2x dx. So if you go through your substitution, a 1/2 will keep producing itself. So 1/2 equal to 2x. Another integral will produce another 1/2. Another integral. Another integral. Okay, you're going to keep going until you reach the 0, the number of times that you took to get to 0. And then you're going to pair diagonal. Well, first assign positive, negative, positive, negative, positive. And then you're going to pair the diagonals.
What's the positive negative for?
So
Actual equation?
yeah, so you know how you get uv minus integral of v du?
Yeah.
So you're basically doing a nested version. So within this, you're doing another,
Reminding.
yeah, uv minus integral of v du. So this negative is going to keep changing the sign over and over again. That's where that. And then you just do this times this, plus this times this times this, and just add. And just make sure that your signs are corresponding.
So pairing them is just the diagonals.
Yeah, just diagonal.
Okay.
Yeah.
Because that will save a lot of time.
It does, yeah. You don't want to do enrichment parts if it's going to be repeated.
Perfect. Okay, thank you.
Yep. All right, 22. Let f be the function defined by f of x. Where's the graph concave up and decreasing and concave up? So here, it's not difficult, but you just want to make sure that you create both your sign lines and then line them up nicely so that you can see where the behaviors are lined up, where you're gonna get decreasing and concave up. So you spend the time to find f prime, create your sign line for f prime, find f double prime, create your sign line for f double prime, and then you line up your numbers with your behaviors of slope and concavity. And decreasing and concave up will be from 1/2 to 2. Okay, 23. You have a piecewise function. What's f prime of -1? Well, in order for f prime of -1 to exist, these functions, not only are they going to be connected, they have to share the same slope as well. So I can just find the slope of both derivative for both these functions and see if their slopes agree. Right? If their slopes don't agree, then I'm not going to have a nice differentiable function. So f prime is going to be 3. And then to the right, it's going to be -2x. So if I want to find f prime of -1, as we approach -1 from the left side, -1, we see it's going to be a slope of 3. But if I plug -1 on the other one, I'm going to get a +2. So there's going to be a sharp turn. So it's 3 all of a sudden changing to a +2. We know that that's not going to be I'm not going to be able to remember with any graph if there's any sort of a sharp directional turn. If there's not a smooth transition, we know the slope doesn't exist. Which of the following is a horizontal asymptote? Horizontal asymptote, another way of thinking about this is your limit as x approaches infinity or approaching -infinity. So the nice thing here is if you're approaching infinity or -infinity, you can just compare degrees. Careful though, you do want to FOIL this out so you can clearly see the coefficients in play here. So let's FOIL everything out. I see my numerator. Its highest degree is x squared. My coefficient is -12. Denominator, my highest degree is x squared. My coefficient is 4. My limit is -3. Okay, 25 is a bit of a mess, but 25 says if y equals x squared minus 2x and u equals 2x plus 1 dy over du. So what they want is they want you to create an equation where the x is not the independent variable. It's going to be for u. So I can replace all the x's with u's, right? Because if I solve for x, x is u plus 1, u minus 1 divided by 2. If I can get my equation in terms of u, then I can find dy over du. Instead of dy over dx, it's dy over du. So I cleaned everything up as much as I could. I found the derivative, and then I replaced the u back in terms of x. It's a little bit strange, different from an AB side of things. You just see ones like this. I wonder if there's another way to do it. Maybe it's going through chain rule, but this is the way I did it. So once I got everything in terms of u, I replaced u back in terms of x, cleaned it up, and I saw that my answer choice is going to be x minus 1. Okay, number 26. You notice there's a derivative in front of an integral. You know that this is basically a setup for second theorem. So just have to apply the rule, f of p of x times p prime. You know your lower bound is going to be a constant. It will just go away. So plug the upper bound into the variable of the expression, and then multiply your expression by the upper bound's derivative.
Is this a quiz question?
Yeah, either very similar, or I may have pulled it from here. So you can see how these multiple choice can usually they're kind of quick hit problems. But if you get stuck on the long problem, don't try not to spend too much time on it, at least not in the first time around, right? Try to, if you see a problem that feels like it's too long, circle it and then come back to it. That's what you're gonna skip. Yeah, you come back to it. Come back to it. Do the AB problems first.
Vectors is easy though.
It can be, especially if you know the formulas and just apply them. Okay, 27, particle moves on the x-axis. Well, what value is the particle at rest? You know particles at rest when your velocity is 0, but first we got to get to the velocity. To get to the velocity, we got to go through chain rule. Sine of u becomes cosine of u times u prime. 2 pi t becomes 2 pi. If I try to solve for t, I can subtract 2 pi from both sides. Divide both sides by 2 pi, I get -1. So I'm sitting at this point here. I can use inverse cosine to help me solve for t here. So I'm going to move this cosine over to the other side here. So 2 pi t equals inverse cosine of -1, basically asking when is cosine equal to -1. So cosine is equal to -1 when theta is pi. Right, so cosine of pi is -1. So that's, I can replace that with pi and then solve for t, divide both sides by 2 pi. I get t equals 1/2. Or you can just do guess and check different values for t that will allow cosine of some value to be -1. Okay, which is the following differential equation for the slope above? We can tell that this horizontal line is indicating that there is a slope 0, and slope 0 must be at y equals 1. And we see that pop up over and over again. So it must be one of these options involving y minus 1. So now I'm just looking at what can kind of give it away, or what can I do to eliminate the wrong choices? I know b is out because if I factor that x out, I get y plus 1. I know that there is no slope 0 and y is -1. That's definitely not true. I plug in C, if I plug 1 in for Y, I'm not getting a 0 in return, so C is definitely not indicating. Anything above, anytime where Y is positive, I should be getting, at least in the first quadrant, a positive slope. So positive slope basically in the first and third quadrant. Negative slope basically in the second and fourth quadrant, assuming that you're now looking at what's between 0 and 2, 0 and 1. So I'm just testing different values here. So for D, if I plug -1, -1, I'm getting a positive value here, but if I plug in -1, -1, I'm getting a negative value here. So I know this one is out. And y minus 1 cubed, I'm testing another order pair here. I'm seeing that this is giving me negative, but then over here it's showing me positive. Okay, so allows me to narrow down my choice just to option A. Okay, we can stop there and we can pick up on page 27.
Thanks, Jim.
Take care, guys. See you
I
tomorrow.
don't even know if the top we have would be, again, for the second one is the x cubed times the x.
Oh.
Yeah.
Oh, okay, okay, this one here.
Yes. Yeah.
Oh, cosine.
Thank you.
I see that. Cosine becomes sine.
Would be negative. I mean, not negative, sorry.
Yeah. And there. So then. This times this will be negative x cubed 1/4 sine 2x. Minus 3x squared times 1/8 cosine 2x. Plus 6x times 1/16 6 sine 2x. Minus. Or plus 6/32 cosine 2x plus c.
Okay, yeah.
Yeah, that'll save you some time.
Yeah, I'll be a lot less stressful when I
Yeah.
have some.
If you see natural log though, you gotta go through
Yeah.
parts, you can't do it now.
It's the.
Yeah, you gotta get through it with all of natural log.
Alright. Alright, thank you.
Yeah.
Crazy, I forgot like chain rule is the thing when it comes to like trig, it's just like natural.
Oh, yeah. You just apply it without even thinking.
Yeah, it's just.
You don't call it